Hello everyone, this is Priyanka K studying at Sri Venkateshwara College of Engineering. Today in this video we'll be looking into recursion. Firstly, we'll see what is recursion. Recursion in Java, recursion is a process in which a function calls itself directly or indirectly is called recursion, and the corresponding function is called recursive function. Using a recursive function algorithm, certain problems can be solved quite easily. A very few Java recursion examples are towers of Hanoi, in order or pre-order and post-order tree traversals. Here comes the base condition in recursion. The base case for n is less than or equals to 1 is defined, and the larger value of the number can be defined or solved by converting it to the smaller one till the base case is reached. Next, we'll move on to the working of recursion. Working of recursion is an idea to represent a problem in terms of one or more similar or smaller subproblems and add small base conditions that stop the recursion. For example, we compute factorial n. If we know the factorial of n minus 1, the base condition or case for factorial would be n equals 0. And then we return n equals 1 and n equals 0. Next, we'll see an example for factorial using recursion. In this code, there are two classes, GFG and recursion. The GFG class has a method called that is factorial, which is used to calculate the factorial of a number. The method is defined using recursion, which means that it calls itself until it reaches the base case. The factorial method takes an integer parameter n and returns a integer value. If the value of n is equals to 1, and it returns the value 1. Otherwise, it recursively calls the factorial method with the parameter n minus 1 and multiplies the result with n. Then the recursion class is the driver class which contains the main function. In the main function, an object of GFG class is created using the statement GFG f equals new GFG. Then the factorial of different numbers 3, 4, and 5 is calculated using the method of GFG class and printed out using the system.out.println statement. So when you run this code, it will calculate and display the factorial of 3, 4, and 5, which is 6, 24, and 120. Next, we'll move on to how is memory allocated to different functions called in recursion. When any function is called from main, the memory is allocated to it on the stack. A recursive function calls itself. The memory for the called function is allocated on top of the memory, which is allocated to the calling function, and a different copy of local variables is created for each function call. When the base case is reached, the function returns its value to the function by whom it is called, and memory is deallocated and the process continues. This is an example for using different function calls in recursion. In this example, we have a class called GFG. Inside the class, there's a static method called print function that takes an integer parameter called test. The print function method is a recursive method that prints a sequence of numbers in a specific pattern. Firstly, if the value of test is less than 1, the method returns and the recursion stops. If the value of test is greater than 1 or equal to 1, the method executes and follows the steps. Like it prints the value of test using the system.out.println statement. If the function calls print function method again with the parameter test minus 1. This is the recursive part where the method calls itself with a smaller value of test. After the recursive call, it prints the value of test again. In the main function, an integer variable test is declared and assigned a value of 3. Then the print function method is called with a test variable as an argument. When you run this code, it will print the numbers in the following pattern. 3, 2, 1, 1, and 2, 3. The pattern is achieved by the recursive calls and the order of print statements. Next, we'll see advantages and disadvantages of recursive programming. We'll see advantages of recursive programming. Recursion provides a clean and simple way to write code. Some problems are inherently recursive, like a tree traversals, like Tower of Hanoi, and many more. For such problems, it is preferred to write recursive code. It also reduces the time complexity, performs better in solving problems based on tree structures. Disadvantages of recursive programming. The recursive program has greater space requirements than the iterative program, as all functions will remain in the stack until the base case is reached. It also has greater time requirements because of function calls and returns overhead. The recursion uses more memory and it is quite difficult to understand. We'll also see direct and indirect recursion differences. A function is called direct recursive if it calls the same function. A function is called indirect recursive if it calls another function, say function new, and function new calls directly or indirectly. In the direct recursion, a function calls itself directly in its own body, whereas indirect recursion typically involves at least two functions. A function calls a second function, which then calls the first function again. Example for indirect recursion. For instance, function A calls function B, which calls function C. If function C, under any circumstances, calls back the function A, this case is called indirect recursion. Direct left recursion occurs if one in one derivation step. Indirect left recursion takes more than one step. There are many types of recursion. There are several recursion such as direct recursion, mutual recursion, multi-recursion, and recursion. Direct recursion is typically defined by the factorial implementation where the method calls itself. Mutual recursion, this happens where only one method, say method A, calls method B, which then calls method A. This involves two or more methods that eventually create a circular call sequence. Multi recursion is also called as multiple recursive calls are made in the method. Head recursion, in this type, the recursive call is made at the beginning of the method. Difference between tailed and non-tailed recursion. Tailed recursion function is said to be tailed recursive if the recursive call is the last thing done in the function before returning. The base case is handled at the end of the function after the recursive call. Tail recursion can be optimized by compilers to use a constant amount of stack space. Can be optimized for all tail call eliminated, improving stack space efficiency. Non-tail recursion. A recursion function is said to be a non-tail recursive if the recursive call is not the last thing done in the function before returning. The base case is handled before making the recursive call, and the tail recursive uses more stack space because each recursive call creates a new frame on the call stack. It cannot be optimized for tail call elimination, which can lead to stack overflow errors.